Hello, my student. We are going to talking about the mechanical property of materials for the chapter 6. And this is going to be the last chapter for our material testing. And following this, the main thing that you, as an engineer, you will encounter with the various material, which maybe include the structural steel, the concrete, the timber. Timber is the word for the wood, the brick, the aluminum, and the fiber reinforced plastic. Since you encounter many types of material and each material have their own characteristic, so you got to select the material properly in your analyze and design of the structure in order you to use it effectively. Before you can do that, you got to understand the mechanical property of each material. Okay, since they are different, as I mentioned before, that is going to be the learning objective of this chapter. And following this, after finish this course, you may have a chance and you may select the correct material for the structure. Let's you consider this tall building. This also called the high-rise building. Okay, high-rise building. And let's say if it's construct, okay, in the middle part of Thailand, such as in Nakhon, Ratchasima. Okay, if you are an engineer, what the material you are going to use? Okay, since in Nakhon Ratchasima, the soil are strong, unlike the one in Bangkok, that is the clay. We are in the location of the Petra of Thailand, and our soil have strength. And most of the foundation that we use is the reinforced concrete with the slab foundation. Okay, and then when you construct it, you are going to use the steel at the structure or the reinforced concrete at the structure. You use one steel. You have the choice of reinforced concrete, or you may also have the choice of pre-stressed concrete. Nowadays, okay, the reinforced concrete usually can be used for the column of the structure. Okay, and reinforced concrete, you have the concrete, and you have you put the steel inside it. So the reinforced concrete is a composite material. That's combination between the steel and the concrete working together. And some column in a high-rise building not only have that rebar in the column, it's sometimes they put the steel, structural steel inside it. This also help the concrete to taking care of the force, and it can reduce the section of the column of the high-rise building. And for the slab, okay, for the slab, mostly in the high building they use the pre-stressed concrete slab, and most of the time you may hire large companies such as Siam Cement Group to do the slab design and do the pre-stressing of the rebar to make the pre-stressed concrete in the building. Okay, and then the facade of this building most of the time is built by the composite structure, such as in our intersection between University 1 Avenue and the 304 highway. We have a structure over there, and that's beautiful, very vibrant in colors. That's built by using the composite. The composite is mostly built by the aluminum. Okay, and if you have the aluminum structure, the aluminum will be very water resistant, and also is lightweight, high strength. And the wall in the building may be using the brick, especially in the area of uh, of structure that require soundproof. Okay, and also we have the modern materials such as the fiber reinforced plastic. I have my research in this when I doing my PhD in the US. They use this a lot. But after I come back to Thailand, I take this technology with me. But the acceptance of this FRP is very slow. Now we have graduate from SUT working on this. He is selling the what's so called the Patut fiber reinforced plastic rebar. Okay, and you can search it by using the Google. This rebar is using instead of the steel rebar. Is very good in the area such as in the seashore or in the water treatment plant, in which the environment is very harsh for the steel. Okay, this is the example that you guys going to use this knowledge of mechanical property of the material in our civil engineering application. Okay, let us review the typical construction material that we are using. Structural steel. Structural steel can be have like a Slab bar, RB. Is maybe Deform Bar, DB. This is used in the reinforced concrete, or the pre-stressed strand, that is used for the pre-stressed concrete, or it may have the structural section. We have the H, I, C, sometimes L, sometimes C. You have various sections. Second is a concrete. Okay, the concrete usually have the normal strength concrete. It's the normal concrete that is used in typical structure. And some high-rise building or special structure, we can use the high-strength concrete. Okay, usually it has the ultimate stress F pounds of C larger than 400 kc. Okay, and nowadays it's changed to 600 kc. Is up to the standard of each country. And in Thailand, you can order the ready-mix concrete with the strength up to 800 kc, kilogram per square centimeter from SCG or from TPI or from the other company. And the third, these two materials are very popular in Thailand. And the third is a timber. Many years ago, 100 years ago, normal people build house by using the timber, and rich people build house by reinforced concrete. But nowadays, technology changed. Only rich people can build house by timber. I mean luxury house. Okay, because timber nowadays is very expensive. There is some kind of business in the US or in the western part of our globe in Europe. They use the commercial forests. Okay, they plant the engineering wood, and they use the technology produce the engineering timber, such as the one that we study in the mechanics of material, like what's so called a gulab. Okay, they put small piece of wood and attach together by special glue and some kind of curing that can produce small wood into the large wood. And the third is the brick. Okay, typically we have two types of brick. One is the clay brick. Okay, that is typical old style brick. Another one is concrete masonry unit. It's the concrete. That is the concrete. That is the brick unit. That's built by using the concrete here. And the fifth is aluminum. Okay, aluminum have anything you have can have structural aluminum in the high-rise buildings such as in Hong Kong or Taiwan. They use the high-rise building with glasses for the facade of the building to let the light go to the building. That can save some energy. Okay, because the country over there in the summer, in the winter, is going to be very cold. So the sunlight can provide the light to the structure and provide the heat to the structure. And the cladding that support all this window made by the aluminum. Okay, that is going to call it structural aluminum. And there is another non-structural aluminum. You can see from the ceiling of the academic building one. That's all the ceiling is built by non-structural aluminum, and then they put like a plate of wood between the aluminum and then produce the ceiling of the roof. And the last one is a FRP. So it is your duty to select the material properly in the design and analysis of the structure. I show this picture to you to mention something about the construction industry lately. It's very, very prosperous in Asia. This first one is the Kingdom Tower. This is going to be the highest, tallest high-rise building in the world. It's going to be in Saudi Arabia. This is follow the high-rise building nowadays is tallest one is the Burj Khalifa. It's built in United Arab Emirates in Dubai. Since the Dubai is a small country and have the high-rise building, that's why Saudi Arabia said, I'm going to build another one that's taller than you. That's competition. Build the competitive environment in our civil engineering. And then there are a lot of high-rise building occur in this world. In Thailand, we have the superstructure. Okay, this is 615 meter height. It may not be the highest one in the world, but it's the highest one in Thailand. And also this structure has some kind of glasses facade, and build this one really beautiful, and it requires some application of the high strength steel and the high strength aluminum. Anyway, when you build a structure small or tall or big or very large, you're going to consider three things. Your material that you use in the building must have enough strength. Okay, won't produce any crack under the force, won't cause the yielding under the loading. Just strong enough. And the deflection of those material using to build the structural member is supposed to be very small. Large deformation cause the structure lost their function, and also sometimes cause very high vibration. So this building seems unsafe for the people. And the last one, the structure supposed to long lasting, supposed to very durable under the weathering from the rain, under the action of the wind. Okay, that is very important for you to consider the material. So what kind of question you should ask when you are selecting the proper material? The first one, what type of material that are available in the market? For example, if you like to use the concrete with the strength of 1,200 KSC. That's going to be very expensive because it's very rare to use that very high strength concrete. Okay, and in Thailand, mostly you have two choices to build the structure. One is the steel and one is the concrete. Okay, and the concrete can be RC or can be PC. And what else do you use for this? The mechanical property. Okay, you're supposed to compare them. The steel is kind of ductile material. The concrete is kind of brittle material. And then you reinforce the concrete with the steel. So you produce a composite structure that's appropriate, more ductile. And then compared to the strength, the steel have higher strength and higher stiffness when compared to the concrete. But anyway, the steel are susceptibility or less durable for the weathering than the concrete. When it's wet by the water, it can get rust easily. So the steel, you need to have the rust-proof material to paint it. And sometimes you also need to spray the fireproof material into the steel. Unlike the concrete, okay, concrete won't rust. Concrete is also very durable to the fire. Next, how the maintenance, like I mentioned, the concrete has very high performance for maintenance. Steel require a lot of maintenance compared to the concrete. Needs fire protection and rust protection, but concrete won't. That's why when we doing the reinforced concrete and the pre-stressed concrete, very popular in Thailand because they use both of the advantage of these two materials. When they work together, they help each other more and more. Next, the cost of it. This is hard to compare between the cost of concrete and the cost of the steel. But in Thailand, the reinforced concrete and the pre-stressed concrete are more popular because the weathering in Thailand and the experience. The Thai engineer have a lot of experience with the reinforced concrete and pre-stressed concrete more than the steel structure. Most of the steel structure used in industrial building, okay, like the plants, Honda plant, Toyota plant, those kind of large plant, they always built by the steel. Nowadays, there are some company that trying to use the steel in the building, such as Siam Yamamoto Steel. That I also sent some of information to you already. And what else? How to use that method in the construction. It's about the construction management. Okay, in the past, when you use the steel can be fabricated in the industry. You can cut and then you can drill it and then you can ship it or transportation it to the construction sites. And that's going to be very convenient. And the structure going to be in high quality. Okay, but nowadays the concrete also have some kind of precast, okay, concrete. Okay, it can produce as the concrete plant. Okay, in the concrete plant. So the pre-stressed concrete can be both RC pre-stressed and the PC pre-stressed, going to be high quality also. But the weight of it may be large during the transportation compared to steel. And the installation also harder compared to the steel because the weight of it is a lot. Okay. And how do you spec the material in your contract? That means you got to say for the concrete must follow the Thai industrial standard number year. The same thing, if you spec follow the international standard, you may use the British standard, you may use the American Society for Testing and Material or STM standard. So this is the first thing, okay, that you gonna study for each material, and then you got to push it into the contact. So when the people bidding for the construction of that structure, the contractor must follow this contact, must follow the specification that you as the engineer write it. Okay, and if not, sometimes it's not only the legal problem you may have also suing those kind of thing, and you got to pay back if you didn't follow what you are going to work within the contract you have. And the last one, if you have specification, you got to test it. For example, if you use the FE24 steel following the Thai Industrial Standard 119, and then you buy your steel for like every 10 ton, you got to correct at least 3 to 5 specimens and send it to the lab. That 10 ton of steel, that's cost 300,000 baht. That's quite a lot of money, right? So when you buy things, you got to have the test for the acceptance quality control. That means you are going to use the knowledge of this equation. Actually, most of the time you didn't test it by yourself, but when you get the result from the lab, you can compare with the spec, and then you can decide whether you should accept the material or not. Okay, let's consider this structure that is in Phetchaburi near Lam Pak Bia. That is the King project. Okay, they trying to restore the forest, the mangrove in the area of Phetchaburi, and they have the structure that's for the traveler to have a chance to take a look at the mangrove forest. And you can see this bridge made by what? This bridge made by timber. Okay, why don't they use steel in this area? And this also concrete, the RC column. Okay, they use the steel here because the steel is susceptible to the seawater. It can get less. And if you use the RC column, it's going to be a very special design on this. Okay, such as you put the steel inside it. The covering of this is going to be 3 inches. This is going to be 3 inches or 7.5 centimeter or 75 millimeter. Unlike the column that you use in the typical building, okay, especially the one that's inside the building, the covering here is only 25 millimeter. That means the covering is going to be 3 times larger to prevent the seawater attack the steel in the column. Okay, for the wood, it can take the seawater without corrosion. Okay, let's start about the structural steel. Nowadays, like I said, they are trying to use the steel more and more due to the steel has the high strength to weight ratio, and the industry going up very quick in Thailand. In Thailand, we have many companies such as Bang Sapan Mill Bar, that is in Prachuap Khiri Khan. Also, Saviya Steel Industry, that's also in Prachuap Khiri Khan. Or Siam Yamato Steel, that's in Suranaree. There are many steel companies in Thailand, as they are big also. They are going to produce the product that follow the Thai industrial standard. And like I said, new material can come to this industry. No, it's not. It's very hard because this company is big. Okay, most of the time in Thailand we don't have the steel. We got to import the iron ore. Okay, we don't have iron ore in Thailand. We bought the pig iron, which is the iron ore that's only passing manufacturing process. And this pig iron is going to burn and adjust some percent of carbon. And then we produce some type of structural steel. Okay, and we have many grades of them. Okay, that is the pictures of manufacturing of the steel product. It start with this one occur usually in some country such as in the China or Brazil or Russia, and then this going to produce to be like a pig iron. When it come to Thailand, okay, this pig iron may put into the arch furnace. Okay, sometimes we also have recycled steel and put in the arch furnace. And then there is some special manufacturing process, and they cast the liquid steel, okay, into the slab, thin slab, those kind of things. Okay, that is we have. This is occur in another process. Okay, that is usually we don't have this startup of the steel, but the pig iron can go there. And then the steel may have many types. For example, if you're talking about this beam, okay, the section may be something like this. If we're talking about the purlin here, the section can be the C, and this C, this is Z in Thailand, or C here, because we can connect, okay, the section into the beam of the frame easily, and also we can connect the metal sheet into this purlin or into this beam easily also. Okay, and the construction steel. Typically, we have three types of them, and the first one is the wrought iron. We don't use much wrought iron in the structure, but the wrought steel is used, okay, in the window. My window house also have the wrought iron to protect, okay, the lobster into my house. We use it a lot in Thailand because it can bend easily, and it can subjected to repeated load. So most of the window in Thailand have the bent steel to protect the house. And we use of steel. Steel can be two things. It can be carbon steel, and it can be the alloy steel. For the carbon steel, the main property of the steel is based on the percent of carbon that put into the steel. When you put more carbon into the steel will improve the strength, improve the hardness, and reduce the ductility. That means high carbon steel sometimes have high strength and high surface and less ductility. And if the property of the steel depend on some additive such as silicon, nickel, magnesium, chromium, those kind of things, we call that steel is alloy, such as the stainless steel. Okay, I have a student who work by putting the stainless steel at the reinforcement of the concrete. The stainless steel is good because it can withstand to the weathering from the seawater, from the water, it won't get less, but it costs 3 times more expensive than typical steel. Okay, that is sometimes you going to use this alloy steel, especially if you work in the southern part of Thailand. Okay, this is different steel. Is for the steel with a carbon of 0.11. When you increase the strength of the when you increase the percent of carbon to 0.32 to 0.62, you can see the stress strain curve going up. The strength going get higher and higher when you put you increase in the percent carbon. And also the heat treatment also increase. So the steel property not only depend on the percent carbon, it's also depend on the manufacturing process also. How? Because when you treat the steel with the heat, you heat it up again, and then you control it for cooling step by step. So the grain of the steel gonna get smaller and very smooth. Okay, close to the theory. That's why it's improved the strength by heat treatment of the steel. And the last one that we have is the cast iron. For the cast iron, we put a lot of carbon into the steel. That's going to increase the compressive strength of the material and the surface hardness. This is important in some applications such as the train rail. Okay, since the wheel of the train also the steel, so the train rail must be the steel, and it must be hardened. When the train brake, the force from the train won't hurt the surface of the rail. Okay, and since the rail put the force on the since the train put the force on the rail as in compression, so cast iron is very good for the railway track or the train track. However, since you put the carbon into the steel with high percentage, that carbon cause the micro crack between the steel and the carbon. And then when you put it, what happened is the micro crack open and it's gonna fail in tension quickly, and it's going to have low tensile strength with the brittle failure. Unlike in compression, under compression, micro crack close to each other, and it also have the boson effect. So the cast iron can take a lot of compression. Okay, this table shows you the typical and usage of the steel. Mostly follow the ASTM standard. Okay, we use the mild steel, and for Thai TIS, you may use specified by FE24, okay, or FE30. That is going to be the typical mild steel that we use in Thailand. So anyway, when you decide it, you got to take its mechanical property and follow it closely. There is special steel that's used in some mechanical engineering industry, such as in automotive industry, for the spring, and for some car they use some kind of special steel, such as this one, the medium strength, and that's going to use in many industry also. So in short, when you put the carbon into the steel, the strength going up, hardness going up, ductility going down. You put the alloy in it, it's going to improve some required mechanical property, such as if you put silicon, you increase the strength. Okay, if you put the copper, you got the higher corrosion resistance. if you put the manganese into it, you improve its hardness. Okay, so mostly the property of alloy steel bases on what additive you put it in. Steel have the property of behavior of elastic and plastic behavior. During elastic, that we have mostly we use this as the sigma sub y. The property over here is elastic. That means if you pull the steel and still have 2 centimeter elongation and you release the force, the steel gonna contact to its original length. For example, 1 meter, you pull it to 102 and you release the force, it just go back to 100 centimeter. That means the steel is in elastic behavior. But for example, if you have steel 1 meter and then you pull it passing this elastic region and go to the plastic region, for example 1 meter steel, okay, if you put it small, okay, you got it 1.02 meter, that's in the elastic behavior, right? But if you pull it to 1.10 meter, it's going to come to the plastic region. And when you release the force, it won't go down back here. It will come back, okay, following its original linear behavior like this. So by doing this is going to have some what's so called the elastic recovery, and some going to produce the permanent set. Okay, if you consider what we have in our examination, we also talking about this kind of behavior also. And now what it have is the behavior of this material chain. Usually it has the elastic region up into the last blue, and now it gets larger to this blue line. That means the elastic region get larger and you also get the higher yielding. So this time you may use the sigma sub y change to here. That is good, right? Yes, it's good. But it also has the drawback. Usually it can elongate following this less line. But this one is going to change to reduce to the orange line. So your material is going to get more brittle. Okay, and then the energy absorption of this material also less, since the area under the stress strain diagram reduce. Okay, now after we consider the diagram for the steel production, and then we get the steel plate, and now there is 2 more steel production process that's required. One is a hot working process. Another one is going to be cold working process. In the hot working process, the steel that we have from the previous slide will come to the reheat furnace. And then it has some kind of manufacturing process to make it like a pipe, okay, to make it like a commute, those kind of thing. It depends on what the process you have. Okay, some going to produce the structural mill and some produce the bar and the rod. Okay, most of the time they have 2 things, the slab going this way and the boom and bullet going to be this way. Most of the Siam Yamato cement, Siam Yamato steel or the BSBM Bangsapan bar mill or Savia SVI, they can produce the structural section and the bar section. And hot rolling process, okay, after you reheat it and then you try to control how it's cool, you make the steel more strength and more toughness. by reducing the residual strength and get the finer steel grain, and then you can load it. When you load it, that means you're going to get this one, the structural mill. Okay, you load it, you got the section that's similar to this, like beam. This is for the I or the H or the W section, column, channel, ankle. Okay, this is usually for the purlin or the small structure, and this may be used for the truss. This may be used for the truss member or the column, okay, or the beam. Okay, this more maybe you use to for the small structure like the purlin or maybe some kind of ceiling structure. That's going to follow the Thai Industrial Standard 1227-2549. And for some other country, you got to check what standards they are using. And next, for the whole working process, most of the time this is going to involve with the steel plate. Okay, they put the steel plate into the some process which cause the stain hardening. This will increase the strength of the steel, the surface hardness, but the same as you know, the toughness is reduced. Energy absorption also reduced. This is usually used for colorless section used in a minor structural member. Okay, and then the process produces is called cold rolling. It's cold rolling, not low when it's hot. It's low when it's cold. Okay, and then this must follow the TS 1228. Okay, next, the steel that's used in the construction mainly separate into structural steel, like I said, from the production. Okay, and when it's hot low, you may get the W section, which is the H section. This is American, this is Japan, or the I gonna be like this. Okay, W and H gonna have equal to the width and the depth, but for the I, the width is smaller than the depth. This is the I. Okay, sometimes you may have some other section such as the T, such as the L, such as the C. That is going to be the structural steel. For the reinforcing steel or rebar, we have this is the RB, and another one we have this kind of thing to increase the bond between the steel and the concrete. We call it deform bar. RB usually used for the stirrup. Okay, sorry for the STI. STIRRUP, and the DB usually used for the main reinforcement. The reinforcement. Okay, this is going to be the not clear yet. The main reinforcement is supposed to be in a beam like this, on the beam on the top and on the bottom. For the stirrup, usually it's going to be this one, but this is not clear. This is a big beam. Let's use the DB as a stirrup. So structural steel is going to produce in that section because the section, as I show you, has the high IOA ratio. Example, if you have the steel with this is 3 centimeter and this is 10 centimeter, this is going to have 30. Okay, 30. This is 3 centimeter and 10 centimeter. This is going to have 30 centimeter square. And then you use this one and you produce the section with the plate of this one is 10 centimeter. This is 1 centimeter, and the same 10 centimeter, 1 centimeter. This is going to use the same area of the steel. The moment of inertia of this, let's say this is going to be I1. This is going to be 10 power 3 divided by 12. Okay, you may get this for what? 3,000 divided by 12, and that is going to be centimeter powerful. However, the I here, you may have this one for what? For, let's say this one 1, and then this is going to be 10. This is 10 power 3 divided by 12. Okay, and do plus 2 times of this one. This is going to be 10 times 1 power 3 divided by 12, plus the area here is 10 times 1, and it's going to times this one square. This is going to be 10.5 square. And you can see that this is I2. I2 is a lot larger than I1. So that means this kind of structural section has higher moment of inertia over area ratio. So this material, this section is going to be very effective. Okay, very good to build this kind of special structure. And you got to call them. Okay, it's just called by its section. W is wide flank. It's going to have this kind of section. And this for the I, this S is the American standard, but actually we can have the I section, something like this. This is I section. C is going to be this section. Okay, and then L. Okay, L have both unequal leg and equal leg. And then the symbol here is will follow by the depth, the depth of the section. And the last one is going to be weight per meter of this section. So you got to call them correctly to get a proper section. The method testing of structural steel, you got to follow what we have for the dimension and weight. You got to follow this depend on the steel that you are using for the hot rolling, for the cold rolling, and for the strength and the elongation. Actually, you also can follow the TIS 119. I think it's going to be correct, or the E8. Okay, 119 is going to be FE24, E8 maybe A36 steel. And you don't cut 3 specimen, and the cut you should not use heat. You got to do it mechanical cut, and each of them going to be 1 to 1.5 meter, and each the plate. Okay, the width supposed to be less than S times the thickness, not too much width. Okay. And the detail of this you can do it when you go to work. Okay, for the TAS 55, that is for flat and square steel bar. Okay, you got to follow this. They will ask you for the yielding, ultimate, and percent elongation, and don't forget about the E. Okay, if this is 2400 kc, 235 megapascal SI, the E is going to be 200,000 kc, or it's about 200 gigapascal approximately. And if you have the hollow section, you're gonna follow the TAS 107. Hollow section has a symbol of hollow H, and S is section, and then it's spec by 41. That is spec by ultimate stress, not the typical yielding stress. And if you go to the structural section, that's hot loading, cold loading, you get of FE24. This 24 going to specify your yielding stress. This is follow the Thai industrial standard TAS, and you may see Our unit is kilogram per square centimeter. So you got to beware on that. Now we come to the reinforcing steel. You know this one. This is for the reinforced concrete. Okay, we put the steel in a proper manner, following the design that we specified it. Okay, and then we put the formwork to cover it, and then we pour the concrete. And when the concrete harden, the concrete will cover the steel, and they're going to work together as a composite material. We put the steel into it because that's going to help the concrete to resist the tension force, because the concrete have very low tensile strength. It's about 10 to 15% of the composite strength. Another one is concrete also can help to reduce the creeps. Okay, the creep. For example, if you have the cantilever like this, and since the concrete, they have not only the concrete have the sand and the crushed stone inside it, and it have the air void. Okay, air void. And in the air void, they have water in it. And when it's subjected to the force, okay, this part going to be in compression, and then the water gonna to leach out from the air void. And what follow is when the water out, so this beam may defect like this. Okay, and when the force release, it won't go back, it won't rebound back due to the creep. One of the thing is you got to put the steel into this portion in the proper amount. Okay, the steel will help the concrete to taking care of the leach out of the water, and the creep can be reduced. The same thing as for the reduce the width of the crack. We have the temperature steel. That's produce the crack due to the change in the temperature of the slab. The reinforced steel is a mild steel. Usually they have very low carbon. Okay, and you can see each kilogram may cost you 30 baht. And then if you buy it for like 10 ton or 20 ton, that's going to cost you 500,000 baht. So you got to be really careful when you check the steel. When you check the steel, you may have the symbol like this. This RB is follow the Lao bar. This 25 is going to tell you about the diameter. Okay, and this is going to be the trademark of the steel. This is going to be some kind of company, and then the grade of the company of this is SR. S is steel, R is the Lao. Okay, and then it's only have one grade of 24 for this Lao bar, and you got to check it. And we also have some kind of deform bar. The picture show is deform bar. We have deform bar because we have this to increase the bond between the concrete and the steel. And the steel must be very ductility. It must be bent like this. We got to bend the steel because we're going to increase the bond again between the concrete and the steel. Okay, the first one, the Lao bar, as I mentioned, is RB. Okay, RB is RB. Depend on the size. This RB6. This is 6 millimeter. If it's 28 millimeter, it's going to be RB28, and it has only one gauge of SR24. The tensile strength must be larger than 2,400. Okay, in the standard that's goes by, they're going to sell us for 10 meter length. We cannot longer than that because it's hard to put into the truck or put into the tin wheeler. Okay, you got to take this. And then what we have is the table of this Lao bar. Okay, you got to check the diameter when you sink it. There's going to be some allowable for this. You got to check the weight of it. Okay, and this Slab bar must follow the TAS 20. Okay, TAS 20. The Slab bar must be have the smooth surface without crack. And then cross section must be round and uniformly along its length. And you can have two ways to determine the diameter. You may use vernier as you did in the lab. Okay, putting in 3 points and do the average. Or you may weight it and then put into this equation. And the discrepancy is this. Okay, it cannot be larger than this. However, even though it's within the discrepancy, what happens is when you test its mechanical property, it cannot less than specify sigma sub y, sigma sub u, percent, elongation, and e. For the mechanical test, you got to follow this. Okay, and then when you get the result, just compare it with this value. If one of them cannot pass this, you got to reject that material. Take it out from your construction site and bring in the new one. Okay, and the bend test is like this. This is showing the bend test. When it's bend test, we should not have crack around here. We bend it because we try to increase the bond between the concrete and the steel. The deform bar have the lips, okay, on the surface, and the lip must be designed properly as specified here. Okay, and the detail you can read it by yourself. The deform bar have the symbol of dB, and it said it's dB10. That is the deform bar with a diameter of 10 millimeter. If it's D bar 20, that's going to have diameter of 20 millimeter. Okay, the diameter is important because the spacing between the rebar, okay, must be larger than 3D spacing, because to reduce the stress concentration, something like that. So the size of spacing is important, and this is the table for the size and the weight. Okay, and you may say you have this size, and then you got to check what you have for your cross section, and you must follow it. And again, the rebar gonna have the dB here, and also the size here. Okay, this is a company that produces, and this is the grade. Okay, this is the grade of this. It's maybe SD30. Now it's have a SD40. It have a SD30. That's old standard. And now popular is SD40, and the new one is going to be SD50. They are going to develop the strength of the steel in the way that they like to use it less. Okay, to make this structure more and more effective. Okay, so your new engineer, check it out for the SD50. The TIS that you must follow is TS24, and they have a detail. You got to follow the test like this. And I didn't mention this much because you're going to use this when you need, and then you know where you should find it, and just come and check it out. SD30 is said the yielding at least 3000. SD40 the yielding stress at least 4000, and it's going to follow the ultimate the percent elongation like this. If one of this property won't pass, you got to reject it. Okay, you should not accept it. Okay, next we going to check the size. The rebar is hard to check the size because the deform bar have the lip. Okay, so you have only one way to check the size of the deform bar by putting into this equation. You got to weight it. You got to measure the length, and you put it into equation. You get the diameter. The standard of test, there are a lot of standard of tests. The important one is for the reinforcing steel. This is for the RC. This is for the RC. This is for reinforced concrete. For the pre-stressed wire, this is for the pre-stressed concrete. A lot of building is using this. You go by TS425. For structural steel, the section of like I, C, T, okay, you got to follow this. This is hot rolling. This is cold rolling, structural steel. And for the STM, they also have many kind of them. I just put them together here as the reference for you in the future. And what the advantage and disadvantage of using the steel in construction? The advantage, steel have the high strength to weight ratio, so it can be used in the high-rise building and long span structure. For example, this bridge, okay, the span here is very large. If you put this into the concrete, you may see this is going to be different type of the thing. And if you build it in the rough area, in the mountain area, it's hard to transport the concrete into the construction site. So the steel is better to fabricate in the steel plant and put them into some 10-wheeler, some truck, okay, semi-trailer, and move it into the mountainous area. Or even you use the helicopter to deliver it, okay. And the property of the steel is very uniform because most of the time it's built in the industrial environment. Unlike the concrete, you may put it, and when you pour the concrete, the rain may come, and then the property of the concrete may be degraded due to the rain. It has high elasticity. It can really elastic, okay, and it can be have the long lifespan if you maintenance it properly. There are a lot of steel bridge in the US. They have a lot of buildings because in the US, the steel industry is very popular, and some of them may have 40 or 50 years old. Okay, that means you got to maintenance it, follow the proper schedule. And it has high ductility and toughness. It can be used for guardrail when the car hit it. Okay, this one won't break, and it can hold the car within the traffic area and won't fall down into the mountain, something like that. And the last one, it is of construction. As I said, it can be pre-built and put it into the truck, ship into the construction site, and put them into the position. Disadvantage, high maintenance that we talking about before, is have both fire and rust. Okay, you got to put the fire protection. Okay, that's going to reduce the heat that's transferred in the steel. And the buckling is a problem. You can study from the chapter 13 of the mechanics of material, okay, about the buckling material. Okay, you got to check the steel have enough bracing or not. Even though it is too slender, you just put some bracing into the steel. When you brace it, the buckling strength, okay, if you brace at the half of its length, the buckling strength can improve for 4 times. You go back to that chapter, you can see it. It's going to have the problem fatigue, but actually it's not directly due to the fatigue. It depends on the welding. Okay, as I mentioned, usually is have the sigma sub u of, let's say, 4000 ksc, and the endurance limit sigma sub e half of this. That is going to be like a 2000 ksc, and sigma allowed that we use usually is going to be 2500 divided by 2. That is going to be about 1200 ksc. So most of the time, the allowable that we use in the steel design is less than the endurance limit of the steel for the fatigue. So fatigue won't have the problem with the steel bridge, won't have the fatigue problem, but the welding, okay, on the steel have some problem if the welding is not treated properly, such as when the welder finish the welding, they just pour the water into the weld, and that's going to cause the crack in the steel, and it's really prone to fatigue and brittle fracture at very low temperature. This is important if you're going to work in the northern pole, in the area very cold, or in the frozen room, okay, in Thailand. Okay, that's what we have for the first part of the steel, and you're going to have some knowledge of the steel, both the structural steel and the reinforcement steel, and you supposed to specify the steel properly, follow the Thai industrial standard if you work in Thailand, or your country standard. And when you put the specification in the contract, you got to follow that. When the steel shipped into your site, you got to collect some specimen and send it into the university or approved laboratory to get the result. And you compare those results with the one in the contract. If it won't pass what you spec in the contract, just reject that and ask them to bring the new one. Okay, that is important to us. Okay, that is the end of this part.